Hello Year 12 and welcome to the next episode of Mathematical Mowbray Movies. Before you watch this episode, I'd just like you to complete this maths contract please. So it says, I will love maths, which of course you would tick. I will be awesome at maths, which of course you would tick. I will make up great maths jokes. Well, you're naturally inspired by your teacher there. And I will always say maths is the best subject. Well, there's not much competition there. And then if you can just sign here, I'll sign on your behalf. And I will just co-sign here, so that's me co-signing. Of course, the cosine rule is the focus of today's video. I know, a little bit lame, but you know you love it. So let's get on with the work. Just a reminder of where we're up to with all these triangles. So remember we said that a triangle could either be a right angled triangle or it could be a non-right angled triangle, or we call that an obtuse angled triangle. If we're faced with a right angled triangle, then we use either Pythagoras' theorem or we use SOHCAHTOA, depending on what we're told, what we're interested in, the different parts of the triangle that we're dealing with. In the last video, you were looking at the sine rule, and remember we said that you use the sine rule when you're dealing with two angles and two sides. And this, of course, was the sine rule that we used. Sometimes we used it flipped over when we were calculating the sides. In today's video, you're looking at the cosine rule, so the other rule that you need to know when you're dealing with non-right angled triangles. So the cosine rule, like the sine rule, is given to you on your formula sheet, and it's given to you in two different formats, this format and this format. So you need to know when to use each one. So let's have a little bit more of a look at it. So here's the cosine rule with a little bit more detail. Like some of the other rules, like the sine rule, we can use the cosine rule to work out either a side or an angle. We use the cosine rule when we are dealing with three sides and one angle. So when we're dealing with a situation like this, where we're given three sides, or we're trying to find a side, but we're given two other sides and an angle here. So 1, 2, 3 sides and one angle. Or over here, if we're dealing with something like this, where we're given three sides, and in this case, asked to work out the angle. So in both cases, 1, 2, 3 sides and one angle, or 1, 2, 3 sides and one angle. So that's when we're going to use the cosine rule. If we're trying to calculate a side, as we are in this particular case, we use this form of the rule. And this form of the rule, you can see, is actually really similar. If you cover this bit up, it's really similar to Pythagoras' theorem. Pythagoras' theorem, remember, only applies to right angled triangles. So it's actually this bit that we chuck on the end that allows us to use this rule, or this modified form of Pythagoras' rule, on non-right angled triangles. Unlike Pythagoras' theorem, where there was a hypotenuse, we don't have a hypotenuse in this particular case because, of course, there's no right angle. What we do have, though, and what we need to have in order to apply this rule, is that we need to know one side and its opposite angle. So just like the sine rule where we do those pairs, we need to know we'll be dealing with one side and its opposite angle. And in this case, it's always labelled as C. So on this diagram, you can see that I've labelled the angle as C and the side as C. The difference here is that this is a capital C. It's a little bit hard to tell, but this is a capital C. And this is a lowercase c. And in our rule, same thing. This one here is our lowercase c. This one here is our capital C. So this one's the capital, it refers to the angle. Remember, you can remember that it refers to the angle because it comes after the cos. And this one here is our lowercase c. So in this case, we're trying to find a side. And so when we're trying to find a side, we're going to use the rule that has the side as the subject of the equation. We'll look at this one where we're trying to work out an angle in the next video. So let's get into it and see if we can make a little bit more sense of it when we look at an example. So this question here says, calculate the length of the side x. So first things first, I see that this has got 1, 2, 3 sides that I'm dealing with and one angle. So I need to know 3 sides, one angle. I'm going to use the cosine rule. So your brain needs to be thinking that way. I now need to work out which form of the cosine rule I'm going to use. Well, I've just explained that when we're working out a side, we use this, the form of the cosine rule that has the side as the subject. So the one that's got the c squared at the start. So I'm going to use this form of the cosine rule. C squared equals a squared plus b squared minus 2ab cos c. That's the capital C, the angle at the end there. Again, as I said, you get this on your formula sheet so you don't have to remember it. Now I need to label my triangle. Remember I was saying that we always needed that one angle pair, that one angle side pair, so that are opposite each other. So in this case we're looking at these two here. They must be labelled C. The other two sides, A and B, doesn't matter, but these ones must be the C's because it's the side and angle labelled C that we have in our formula. So this is going to be my side C, this is going to be my angle C. A and B, whatever the heck you want, doesn't matter. Okay, then we substitute it into our equation. So here I've got c squared, well I'm substituting in the x for my c, because that was my unknown. A squared, so my A was 14, my B was 8, minus 2. Now remember here there's little timeses in here even though you can't see them. So this is 2 times by A, B, and times by B. Then times by cos of my angle C, which was 50. Oops, sorry. Now if I plug this straight into my formula, straight into my calculator, sorry, this is going to give me x squared. Remember, I don't want x squared, I want just x on its own. So rather than just plugging all of this in, I'm actually going to plug in, because I need to get rid of that squared. I do that by doing the inverse, which is the square root. So I'm going to take the square root of all this stuff, just to get the x on its own, just like we did with Pythagoras. So you could, of course, do that and then square root. It's up to you. You can do it in one step or two steps, whatever you want. So then I'm going to plug everything in. So this is the square root of, I open my brackets, 14 squared plus 8 squared minus 2 times 14 times 8 times cos 50. So I've plugged all that in, I press equals, it spits out 10.77. So the length of my side here is 10.77. Oops, sorry, you can't see. The length of that side's 10.77. Okay, so I'd like you to have a go at working out the length in this question, working out the length of this side. So remember, think, where's the pair, where's the angle side pair, and then use your formula. Hopefully you went okay with that. So I first need to see that this is my angle side pair. So they're the ones I'm going to have to label as C. A and B, doesn't matter what you do. I'm working out a side here, so I'm going to use the form of the equation that looks like this. And then I'm going to plug in the bits and pieces that I have. I'm trying to work out my side C, so this is x squared, because that's my, my C is given by the symbol x. I'm trying to work out that unknown. 6 squared plus 5 squared, because that's my A and B, minus 2. Remember there's multiplications here, so 2 times 6 times 5 times cos of the angle was 70. I'm not trying to work out x squared, I'm interested in just working out x, so I need to do the square root of all that stuff. And then of course I just whack it into my calculator and I hope that it spits out something that's nice. So the square root of, I open my brackets, 6 squared plus 5 squared minus 2 times 6 times 5 times by cos 70, close the brackets, gives me 6.36. So again, that's the length of my side here, 6.36. I always do that little check. Does it make sense in the context of this question? Well, yeah, it does. It's not like I've got an answer that's 120 or anything. It makes good sense. Hopefully you got that right. Okay, last one that I'd like you to have a go at is this one here. It's a little bit trickier. It's got a little bit more going on. So it says Raymond set sail on a bearing of 120 degrees. He's a great sailor, Raymond, for 15 kilometres. So he set sail from this point here on a bearing of 120 degrees, and he did that for 15 kilometres. He then changed direction and began sailing on a bearing of 210 degrees. So at this point, if he's facing north and turns 210 degrees, that's the new direction he starts sailing, and he does that for 20 kilometres. The question here is broken into two parts. The first part says calculate the angle theta in the diagram. So have a go at doing that. Alright, let's see if you got that angle theta before we move on to part B. So here's my angle theta in the diagram. I need to recognise that in this triangle I've actually got some alternate angles. That is, angles that are the same because they form that Z shape. So this angle and this angle would be the same. So I know in this triangle, in this particular diagram, that this angle here is going to be the same as this angle here because we've got that Z shape. I have to think back. If I can work out what this angle is, and I know this is 210, and I know all the way around is 360, I'll be able to do 360 take away the 210 and take away this bit to work out theta. So how do I work this out? Well, to work out that, I need to work out this. How do I work out this? Well, I know that these two angles must add up to 180. So you can see there's a bit of forward thinking in these. So I do 180 take away 120. Oops, 120. And I find that this is 60 degrees, which makes this 60 degrees. So to work out theta, I'm going to say, well, what's 210 plus 60? That's 270. So this bit and this bit together give me 270. So if I know that this is 270 all the way around, theta must be equal to 360 minus 270. So 360 minus 270 equals, 271, equals 90. So this angle here is actually going to be 90 degrees. All right. Now I'd like you to have a go at part B. Oh, sorry, you couldn't really see. Have a go at part B. It says, hence calculate the distance that Raymond is from his starting point. So now I want you to calculate this distance here. Okay, calculate that distance there. And I'd like you to use the cosine rule, even though you could actually do it a second way. But use the cosine rule. Good luck. Alright, hopefully you went alright with that. The first thing I'd do is draw out this triangle without all the mess around it because it gets a little bit confusing. Here's my triangle. I know this distance here is 15 kilometres. I know this distance here is 20 kilometres. I've just worked out that this angle here is 90, even though I've drawn it and it doesn't look like 90. And I'm trying to find this. So straight away I'm thinking cosine rule. 3 sides, 1 angle. I could actually use Pythagoras' theorem here because this is a right angle triangle, even though it doesn't look like it. But I want you to use the cosine rule just to show that you can use it. So I'm going to use the formula c squared equals a squared plus b squared minus 2ab cos c. Again, I whack in what I know and where my pairs are. These two are the pair, they're the c's. So my x is the c. This one here is going to be 90. And then A and B, doesn't really matter which one I choose. So I'm going to go 15 is my A, plus 20 squared is my B, minus 2 times 15 times 20 times cos of, my angle here was 90. It's getting a bit crowded there, sorry. Remember, I'm not trying to work out x squared, I'm trying to work out x. So I have to take the square root of all that. 15 squared plus, it's going to get really chock-a-block here, isn't it? Sorry about that. Hopefully you can still see. And then whack it into my calculator. Oops, can't see that, that's for sure. Square root of 15 squared plus 20 squared minus 2 times 15 times 20 times cos of 90. I close my brackets, gives me 25. So my distance here, x, is going to be 25 kilometres, or the distance that Raymond is from his starting point would be 25 kilometres. Hopefully you got that correct, and well done. That takes you to the end of your work on finding a side using the cosine rule.